Namaskar. The topic of discussion today in this module is on climatology and outline. All of you are aware that the earth is different from the other planets due to the presence of atmosphere, hydrosphere and biosphere. The presence of atmosphere is a unique feature supporting several things on our earth. The air, the sea and the land constitute the major portions of the three global spheres as atmosphere, hydrosphere and lithosphere. Climatology is one of the branches of earth and atmospheric sciences. Climatology is the science of studying the average atmospheric conditions of a region in long term perspective. It includes a systematic study of atmospheric conditions pertaining to the weather and climate. Climatology aims to study the nature of climate, the causes and interpretations of its variation and also its association with the biosphere. It is closely related to meteorology and geography due to the fact that all global atmospheric processes are spatially distributed. Weather is the condition of the atmosphere at any particular time and place. The elements of air temperature, air pressure, humidity, clouds, precipitation, visibility and wind that determine the present state of the atmosphere are called as the weather elements. Climatologists evaluate the long term weather conditions of a vast region over a long period of time. They also study the climate and its distribution on the earth's surface both horizontally and vertically. Climatologists also study the effects of human activities on different components of the atmospheric conditions including the weather and climate. They also evaluate the role of climate and weather on the biosphere and hydrosphere. The primary goal of climatology is to study the unique characteristics of atmosphere in controlling the global climate, origin and types of climates, causes and processes influencing the climatic variations, elements of weather and the impact of climate on humans or vice versa. There are several branches involved in climatology as physical climatology, regional climatology and applied climatology. Agricultural climate, aviation climate, bioclimate, medical climate, macroclimate, microclimate, mesoclimate, paleoclimate and Arctic climate are some areas of special studies included in climatology. The physical climatology is mainly concerned with atmospheric phenomena and climates. Regional climatology deals with the regional variations of the climatic conditions which include microclimate, local climate, mesoclimate and macroclimate. Applied climatology deals with climatic controls of human activities and the application of climatic knowledge in solving unique problems faced by human population. The root for the climatology lies in meteorology. It was Greeks who tried to understand the atmosphere and its influence on the life. The first written records about the atmosphere were given by Hippocrates in the year 400 before Christ. Aristotle brought out the first compendium on meteorology as weather science. It was due to Greeks the world was divided into three temperate zones as tropical zone, temperate zone and the frigid zone. Global and regional study of weather and climate were conducted between 18th and 19th centuries using improved and standardized instruments and sensors. The first classification of clouds was done as early as 1803. The 20th century has witnessed the advancement in tools and techniques to obtain regular accurate data on weather and climate. Satellite based continuous monitoring of the whole globe helps to understand the trends in weather and climate. The subject of climatology involves a lot of scientific concepts, principles measurements and interpretations in addition to the basic understanding of the atmospheric processes. In this episode, about 30 broad areas of the subject climatology are highlighted. The following aspects of climatology are elaborately discussed: conditions of the atmosphere, dynamics of the atmosphere, atmospheric disturbances, world climatic types, and changing global climates. These are the aspects covered in this module. Let us see the first one, conditions of the atmosphere. Under the conditions of the atmosphere, the following aspects are to be understood: elements of weather and climate, structure and composition of the atmosphere, insulation and energy balance, atmospheric temperature, and atmospheric pressure and motion. Let us see the first part, elements of weather and climate. The term weather refers to the sum total of short term variations in atmospheric conditions in terms of temperature, pressure, wind, water vapor, clouds, precipitation and visibility. The term climate refers to the long term aggregate of the weather conditions of a region of the globe in terms of several atmospheric parameters. The weather conditions of a region may vary from place to place and also dimension. Microclimate is the first one. It refers to small climatic region. Mesoclimate refers to the small area of the earth's surface, which may be an acre of land to several square kilometers of area. Macroclimate refers to much larger area, which may be a state or the country. And the last part is the global climate, which refers to the climate of the entire globe. The following are the elements of weather and climate: temperature, air pressure, wind, humidity, precipitation and cloudiness. These elements are controlled by various factors like latitude, altitudes, unequal distribution of land and water, air-sea interface, ocean water circulation and the geomorphological conditions. Let us see the second aspect, structure and composition of the atmosphere. The multi-layered gaseous envelope attached to the planet Earth is the atmosphere. It is a unique sphere of air, gases and water vapor. The height of this huge mass is estimated to range from 16,000 to 29,000 kilometers from the sea level. This is an essential environmental segment for the life support systems of biosphere and also the hydrosphere. Under the umbrella of climatology, the structure and composition of the atmosphere are studied first. An understanding of the thickness and disposition of different layers like troposphere, stratosphere and mesosphere are also needed. The vertical variation in temperature and concentration of gases have a significant impact on the global scales. The layer concerning with weather and climate is the troposphere. Atmosphere is composed of three major constituents as gases, water vapor and aerosols. Some are permanent or constant gases and some are variable gases. They obey Boyle's gas law, Lusak's law, Charles' law and combined gas law. Let us see the next aspect, insulation and energy balance. The energy system of the earth involves solar radiation, gravity and geothermal sources. The solar energy plays a significant role in heating the earth's surface and also the atmosphere. Because of this, it is responsible for the movement of air and also the creation of oceanic currents. The radiant energy is the driving force for the global water cycle, rock and the biogeochemical cycles. Without sunlight, there is no photosynthesis in plants and there may not be any food for the other life due to this. Climatology involves the study of insulation, flow of energy, absorption of radiation, emission of radiation, distribution of radiation, heat budget or energy balance and the human influence on radiation balance. The sun is the ultimate source of energy on earth. Radiant energy is the energy propagated in the form of electromagnetic waves. These waves do not need molecules to propagate them, and in a vacuum they travel at nearly 300,000 kilometers per second. Insolation is maximum at tropics and decreases towards the poles. 75% it is lying at the equator, and 50% is seen along the Arctic and Antarctic circles, and 40% of insolation is seen at the poles. The factors which are responsible for the heating and cooling of the atmosphere are radiation, conduction and convection. Let us see the atmospheric temperature. Sun is the major source of temperature in the atmosphere and also in the oceans. Heating and cooling of the atmosphere is controlled by direct sunlight. There is also a transfer of energy from the earth through convection, conduction and re-radiation. The process of heating of the atmosphere are convection, which refers to the upward movement of air, conduction, which refers to the high temperature and low temperature zones, and the radiation, which refers to the emission of radiant energy in the form of heat from a body. Re-radiation also heats the air. Climatology involves the study of transfer of heat energy, heating and cooling of the atmosphere, mean temperatures, distribution of temperatures in the atmosphere, inversion of temperature in the atmosphere, role of temperature in other environmental segments like hydrosphere and biosphere. The heating of the atmosphere involves radiation, conduction and convection. The proportion of solar radiation falling on a non-luminous body which the later reflects is known as albedo. It is the reflective quality of the surface. The albedo of the earth is 0.3. It refers to 30% of the solar radiation reflected back to the space. The distribution of temperature varies horizontally and vertically. The uneven distribution of temperature comes due to the latitude, distribution of land and sea, relief and altitude, ocean currents, planetary winds, vegetal cover, nature of the soil, the slope and the aspect. Let us see the next one, the atmospheric pressure and motion. Air is a mixture of gases and hence it has its own weight. Air exerts pressure. Atmospheric pressure is maximum at the sea level. It decreases with increasing altitudes. Air pressure varies vertically and horizontally. The distribution of atmospheric pressure is controlled by altitude, temperature, air circulation, earth's rotation, water vapor and other factors. Hence, climatology studies the pressure gradient, pressure types, variations in atmospheric pressure, horizontal distribution of air pressure, pressure belts and shifting of pressure belts, atmospheric motion and air circulation, geostrophic wind and gradient wind, wind direction and speed and the classification of wind. The horizontal distribution of air pressure depends on the air temperature, earth's rotation and the zones of high or low pressure. See the second part, the dynamics of the atmosphere. Under the concept of dynamics of the atmosphere, the following aspects are to be understood: the atmospheric circulation, the local and seasonal winds, atmospheric humidity and condensation, fogs, their origin and types, clouds, their origin and types, precipitation and its distribution. Let us see the first part of atmospheric circulation. The movement of air in the atmosphere is known as atmospheric circulation. Atmospheric circulation denotes the motion of air due to the pressure gradient from the local to global scales. It has spatial and temporal patterns of circulation components. It involves primary circulation or long term circulation, secondary circulation, seasonal circulation and diurnal circulation. The primary circulation refers to the trade winds, westerly winds and the polar winds. The secondary circulation refers to cyclones and anticyclones. The seasonal circulation refers to the monsoons and air masses. The diurnal circulation refers to the land or sea breezes, mountain or valley breezes. Atmospheric circulation, speed and direction of winds are controlled by various factors like gravitational force, pressure gravitational force, Coriolis force and the friction force. When a wind above 600 meters height blows parallel to the isobars, it is called as geostrophic wind. Jet stream is a strong wind blowing from west to east at high altitude, usually near tropopause, that is at an altitude of 12,000 meters. It may be about 110 kilometers per hour in summer, 190 kilometers per hour in winter, and also varies from place to place. Climatology hence involves the evaluation of the zonal circulation of atmosphere as global wind belts, tropical circulation which includes doldrums, westerlies and trade winds, mid latitude circulation, polar circulation, meridional circulation and jet streams, El Nina and the La Nina. Let us see the next aspect of local and seasonal winds. Wind is the circulation of air relative to the surface of the earth. Climatology hence analyzes the local and seasonal winds in detail. The periodic local winds include the breezes between land and sea and the breezes from mountains and valleys. The non-periodic local winds include the hot local winds and the cold local winds. There are some more types of local winds as beneficial local winds and non-beneficial local winds. Monsoon is a complex phenomena of the atmosphere. It comes due to thermal concept and dynamic concept. The thermal concept refers to the origin of monsoons. Monsoon refers to the annual cycle of dryness and wetness with seasonably shifting winds produced by changing atmosphere and pressure systems. The study of seasonal winds provides detailed large scale information on monsoons. Monsoon is a flow pattern of the general atmospheric circulation over a wide geographical area with a clear and dominant wind in one direction during one season and in reverse direction during the other season. Hence, climatology involves the study of monsoons, their origin, types and distribution. The seasonal characteristics of Indian monsoon are also studied under climatology. The atmospheric humidity and condensation are two more aspects to be studied. The term humidity refers to the amount of water vapor present in the parcel of air having a unit volume and temperature. Water vapor is released during the process of evaporation from the water bodies of the land and oceans. Since water vapor is a very important constituent of the atmosphere, it plays a significant role in controlling the climate. It is present up to a height of 5 kilometers from the earth's surface. Condensation is the process of converting water vapor into liquid and solid forms. Atmospheric water undergoes phase changes through the exchange or transfer of heat energy. The energy in the form of heat required to carry out all these conversions is called as the latent heat. Climatology hence deals with the elements of the hydrologic cycle, including the humidity capacity of the air, types of humidity and their measurements, evaporation and its rate, and evapotranspiration, condensation and forms of condensation, cooling of air and the adiabatic change of the temperature, stability and instability of the atmosphere. Let us see the importance of fogs and their origin and their types. Fogs are special types of clouds constituting minute water droplets existing in suspension in the air near the ground surface. Fogs generally reduce the horizontal visibility. Fog is formed when the moist air becomes saturated and reaches its dew point. Further cooling of this mass make the water vapor to condense around the dust particles and create the dense smoky fog. There are a dozen bases of classification available in climatology to study the types of fogs. The major types of fogs studied are radiation fog. These are the fogs produced over land when radiational cooling reduces the air temperature below its dew point. It is also known as ground fog or valley fog. The second one is the steam fog. It comes due to evaporation or mixing fog. The third one is the upslope fog. It is the fog formed as moist stable air flows upward over a topographic barrier. The next one is the tropical air mass fog, and the next one is the frontal fogs. Fogs are distributed in different parts of the world. Hence, climatology analyzes the effects of fogs and the natural or man induced dispersal of fogs. Let us see the next aspect of clouds, their origin and types. Clouds are the aggregates of innumerable tiny water droplets in the atmosphere above the ground surface. Clouds are formed due to the condensation of water vapor. Global patterns of precipitation depends on the clouds. Clouds play a significant role in controlling the heat budget of the earth's surface. Hence, the study of clouds involves the classification of clouds and the characteristic features of the clouds. The structure, altitude, occurrence and appearance of the following types of clouds are studied in climatology: cirrus clouds, cirrocumulus clouds, cirrostratus clouds, altostratus clouds, altocumulus clouds, nimbostratus clouds, stratus cumulus clouds, stratus clouds, cumulus clouds and cumulonimbus clouds. These are all the types of clouds which are studied under climatology. Cloud is an aggregation of moist droplets and ice crystals that are suspended in air and are great enough in volume and density to be visible. Condensation is the process of change of matter in the gaseous state to the liquid state or solid water state. Next comes the precipitation and its distribution. The term precipitation refers to the fall of atmospheric moisture either in the form of liquids or solids. Climatology includes the study of precipitation, its measurement over space and time. The forms of precipitation includes rain, drizzle, snow, ice pellets, hails and sleet. Among these, rain is the most widespread form of precipitation. There are three types of rainfalls as convectional rainfall, orographic rainfall and cyclonic or frontal rainfall. The global distribution of precipitation is very wide. The mean annual rainfall of the globe is 970 millimeters. The factors controlling precipitation distribution are the moisture content of the air, the convergent or divergent air circulation, the topographic conditions and the distance from the source of the moisture. In addition to this, climatology also includes the study of various rainfall regimes. They are the equatorial rainfall regime, tropical rainfall regime, monsoonal rainfall regime, continental rainfall regime, Mediterranean rainfall regime and the maritime rainfall regime. The third part as the atmospheric disturbances. Atmospheric disturbances includes the basic understanding of the air masses and the extreme events in the atmosphere. The term air mass is used to denote a large body of air whose dominant physical properties are more or less uniform horizontally and vertically. for hundreds of kilometers. The temperature and moisture are the two major properties. Air mass controls the weather conditions of an area. It plays a major role in the transfer of energy in the atmosphere through its movement. Air masses are subjected to thermodynamic and mechanical modification. Due to this, air masses are divided into cold air and warm air masses. Climatology attempts to classify the air masses based on the thermodynamic and geographical factors. The term air front is used to denote the sloping boundary between two opposing air masses having contrasting physical properties. These properties are temperature, humidity, pressure and wind direction. Air fronts differ from each other in terms of their location and spread. The term front genesis is used to describe the process of formation of new fronts and the decaying old fronts. The conditions responsible for the front genesis are the temperature difference and the opposite directions of air masses. Air fronts are classified based on their characteristics as warm front, cold front, occluded front and also stationary front. Earth's surface has three major frontal zones as polar frontal zone, Arctic frontal zone and intertropical frontal zone. Weather associated with warm and cold fronts are also studied in climatology. Cyclones are the centers of low atmospheric pressure in which air blows inwards in anti-clockwise direction in the northern hemisphere and clockwise direction in the southern hemisphere. Cyclones are considered to be the major atmospheric disturbances. They are classified into extratropical cyclones, which are called as temperate cyclones, and tropical cyclones, which are one of the most powerful and destructive types of cyclones storms in the tropical areas. It is also known as hurricane or typhoon. These are semicircular, elliptical, elongated and V-shaped zones. Anticyclones are opposite in character to those of cyclones. It shows divergent air circulation in all directions from a high pressure center. These are circular in shape, covering a large area. Let us see the extreme events in the atmosphere. Extreme events are those which are originated by natural or human factors causing severe impact on the environment like a hazard. These events exceed the tolerable magnitude in the atmosphere, causing irreparable loss to the life and properties. Atmospheric extreme events include severe storms, lightning, hailstorms and thunderstorms. Tropical cyclones are low pressure systems having a diameter of 650 kilometers, moving with an energy equivalent to 10,000 atomic bombs. They are called as hurricanes in the North Atlantic Ocean and as typhoons in the North Pacific Ocean. The wind speed may be as high as 180 to 400 kilometers per hour, giving a rainfall of 2000 millimeters per day as seen in the Philippines. Thunderstorm develops in three stages as cumulus stage, mature stage and dissipating stage. It may be an air mass thunderstorm, frontal thunderstorm or thermal local thunderstorm. Tornadoes are funnel shaped violent dark storms wherein the upper portion is like an umbrella and the lower portion is like a pipe touching the ground surface. It is a small intense cyclone in which the air is spiraling at a tremendous velocity. It appears as a dark funnel cloud. Climatology also includes the impacts of hazards and their side effects like floods on the planet Earth. The next important aspect is related to the world climatic types. Under the concept of world climatic types, the distribution of climatic types and biomes and the classification are discussed in detail. The world is rich in holding many endless variety of climatic types. The factors that produce the climate in any region are called as climatic controls. Both vertical and horizontal variation of climate are analyzed in climatology. Climate has a spatial scale with an areal boundary possessing identical weather and climatic characteristics in terms of insolation, temperature, atmospheric circulation and pressure, humidity and precipitation. These have a profound influence on vegetation, soil and fauna of different regions of the world. World climates depend on the nature of parameters like temperature and precipitation and their influence over fauna and flora of ecosystems. Several climatic zones have been identified so far. They are also classified based on empirical, numerical and genetic approaches. The important schemes of classification identified so far are the Köppen's classification, which is called as multi-tiered classification system, the Thornthwaite classification of climates, the genetic classification of climates and the composite classification of climates. In the past, climates were determined based on travel, regional knowledge and latitude. Today, climate classifications are based on the causes and effects of climate. The world's climate belongs to three major groups as tropical climates, middle latitude climates, polar and highland climates. There are several subclimates identified based on location, temperature, air pressure, winds, precipitation and effects of climate on vegetation. A biome is a large natural identical ecosystem having unique assemblage of plant and animal communities having a definite distributional pattern in terms of climatic and soil conditions. The world biomes are also classified into three major groups as tropical biomes, temperate biomes and tundra biomes. The next important part as changing global climates. Under the concept of changing global climates, the climatic change, the global warming and the atmospheric chemistry and the weather forecasting are to be studied in detail. The climate is always changing. Evidence shows that climate has changed in the past and there is also evidences that it will also be changing in future. Variation in Earth's climatic conditions are seen in both space and time. The reason behind this variation is the dynamic nature of the atmosphere. Global climate may change due to natural causes and man-made activities. The term climatic change is used to denote the variations in weather conditions over space and time leading to modify the climatic type of a region. The change may occur drastically or gradually. The notable modifications may come in moisture, cloudiness, precipitation and in the heat balance of the Earth atmospheric system. The changes may be cyclic and rhythmic. Similar changes have occurred in the geological history of the past during the ice ages of the Precambrian, Ordovician, Carboniferous and Pleistocene periods. Climate change can adversely affect the lives of the millions. The climatic controls interact to produce a wide variety of different climates. No two places experience exactly the same climate on the world. The similarity of climates within a given area allows us to divide the Earth into various climatic regions. The indicators of climatic changes are biological indicators, geological indicators, cryogenic indicators, tectonic indicators, geomorphological indicators and the historical records of droughts and floods and migration of man and animals. Dendrochronology is one aspect coming under these analyses. There are several theories and causes of climatic changes. In climatology, all of them are studied to understand the past and predict the future. The global warming refers to the increase in global surface and atmospheric temperature affecting the global radiation balance. It comes due to many anthropogenic activities leading to the climatic changes at local, regional and global levels. The rising trend of atmospheric temperatures are after the industrial revolution, and it is the evidence for human factors involved in climatic changes. The increase in air temperature and melting of ice sheets and glaciers are interrelated global phenomena. Ozone depletion due to various environmental factors, including the release of greenhouse gases, is the causative mechanisms of global warming. The global mean surface air temperature has increased up to 0.6 degrees centigrade since the last century. Global sea level has risen by 25 centimeters over the past 100 years. All of these have modified some portions of the atmospheric chemistry, which have shown several environmental effects as a consequence. Weather forecasting is a major field of predicting the weather conditions comprising the temperature of atmospheric air, movement of wind, humidity, sunshine hours, cloudiness, precipitation and atmospheric disturbances over a place or region well in advance. Different sources of weather and climatological data are collected on daily, weekly, monthly and annual basis from global network of observatories and are used to forecast the future. Global life is fully dependent on the knowledge of weather for carrying out various domestic and industrial activities. Weather forecasts are of various types as short range weather forecasts, medium range weather forecasts and long range weather forecasts. Short range weather forecasts are made up to 48 hours. Medium range weather forecasts are made between 3 days and 2 weeks. Long range weather forecasts are done between 2 weeks and 2 seasons. The forecasting methods may include synoptic forecasting methods, statistical forecasting methods and numerical forecasting methods. Weather warning is a forecast indicating that hazardous weather is either imminent or actually occurring within the specified forecast area. Weather watch is a forecast indicating that atmospheric conditions are favorable for hazardous weather to occur over a particular region during a specified period of time. All these aspects are studied in detail under the major branch of study called climatology. Climatology is an important branch of geography.